Okay, let us discuss this problem. So this is find the magnetic induction at point O if the wire carries current I. So there is a point O in this figure. We have to find magnetic induction at this point, and there is a wire. This wire carries a current I. In this case again you have the same situation. Are you getting or not? So this wire carries a current I. In this case again you have a wire that carries a current I. But this point, this current is divided into two parts. So this current is basically bifurcated. Are you getting or not? Now the next part says the radius of the card part is R, capital R. So the radius is given to you. So let us say, and the linear part of the wire are very long. So this part is very long. So let us assume this is a, in this direction this is infinite. But in this direction it can't be infinite. So this is the same infinite wire. So I can assume this is the same infinite. So one thing is clear. So these wires are basically semi-infinite wire. So I will assume this is a semi-infinite wire. Are you getting or not? So this is a semi-infinite kind of wire. Now let me first discuss what is the direction of magnetic field. So if this current goes in this way, I can say magnetic field lines will run in this direction. If current comes in this way, magnetic field lines will run in this direction. You verify yourself using the right-handed rule. So if current magnetic field lines runs in this direction, so due to this wire at point O, magnetic field will go inward, that is minus k direction. So now I know due to this long wire, magnetic field is minus k direction. What about this? So this is again minus k direction. Are you getting? So this will have, it's a downward. So this, due to this wire, again the magnetic field will in minus k direction. What about this? You can use right-handed thumb rule, or other way around. You fold your finger in the direction of loop. So if you have something, a circular loop of something of this kind. So if you fold your fingers in this direction, your thumb will go inside, that is minus I direction. So due to this wire, magnetic field will be in minus I direction. Are you getting or not? Similarly, I can calculate direction for this case. This one, again same thing, minus k cap. In this case, again same thing, minus k. This is a half circular, so this is again minus I. Are you getting or not? Same thing here you have, so this is minus k. This is again minus k. This is again minus I. But what about this? This wire. So this is opposite. So if you fold your finger this direction, so you see if you fold your finger in this direction, because this is a half part of the circle, so your thumb will come outside. Try to see yourself. So thumb will come outside. So due to this part of the wire, that is plus I direction. So due to this part, this is a plus I direction. Are you getting or not? And now things are easy. We have to find the direction I know. Now we have to find magnitude in each case. So let us discuss case number 1. That is the first case. We can calculate the direction. So if I have situation number 1, that is this is the semi-infinite wire. Due to semi-infinite wire, so let us break into three parts. That is B is equals to, vector B is equals to B1 plus B2. So this is vector B1 plus vector B2 plus vector B3. Are you getting or not? Now due to this wire, so this is a semi-infinite, so mu naught I by 2 pi r, and this distance is r. So this is mu naught by 4 pi r cos theta 1 outcast to mu naught by 2 pi r is the full length wire. Full infinite, semi-infinite is mu naught by 4 pi r. So this is mu naught I by 4 pi r. And what is the direction? Minus k. Are you getting or not? And now due to this wire, let us call this as a 2. So due to this wire again minus mu naught I by 4 pi r. And this is again in minus k direction. So why not I should multiply this by 2? That is the same thing. Now due to this wire, that is a mu naught I by 2r, and this is minus I direction. If you have full circle, mu naught I by 2r, half circle, mu naught I by 4r. So this is plus mu naught I by 4r. and now this is in plus minus I direction, you see. So direction is minus I cap. Are you getting? So what I will have, so B is given by, so now I can write B. So this B is given by basically in a vector form. Let us say mu naught by 4 pi if I take common. So this becomes, let us say mu naught I by 4 pi if I take common. So I will have 2 by r here. You are getting or not? 2 by r with a minus k sign. So let us put minus here. And what you will have here, so if mu naught I by 4 pi you have taken common, so pi you will have on the top, and this divided by r, and this is again minus I cap. Now if you take r also common, so you will have mu naught I by 4 pi r. So these are easy problem basically we'll have. So this is just simply calculation 2k minus pi I cap. Now magnitude of magnetic field, so that is if somebody asks what is the magnetic field magnitude, then you have to write Bx a square plus, now it has a two component, x component and z component, so Bx a square plus Bz a square, and this is a common, so I can take this is a common, mu naught I by 4 pi r. Are you getting or not? And this is pi a square plus 4. So this is pi a square plus 4. Simple. Now let us discuss part B. Again I will convert this bar into 3 parts, and we can calculate B is equals to B1 plus B2 plus B3. So you see, this time due to this bar mu naught I by 4 pi r, but this direction is minus k. So let us call this is the bar number 1, this is bar number 2, this is bar number 3. Are you getting or not? So this is your bar number 1, let me put here. So this is bar number 1, this is bar number 2, and this is bar number 3, and I have to find magnetic field due to this bar. So let us say, so first is mu naught I by 4 r minus k. So this is mu naught I by 4 r, and this is minus k. Are you getting or not? Now next one, so let us check. So this is mu naught I by, so this is 4 pi r, not 4 r simply. So this is 4 pi r, so I have to multiply by pi also. Now next one, so circular one, mu naught I magnitude wise is mu naught by 4 r because half circle. And what is the direction? You see direction is minus I. Direction is minus I cap. And third one, what is the third one? So what is the direction? Oh, I have written a wrong direction. This is not in k direction, minus I direction. Are you getting or not? So due to this, because this is in y-z plane, this is in the y-z plane, this is again in the y-z plane. So this to this magnetic field line will run something like this. Are you getting or not? If magnetic field line run into this direction is basically not minus k, this has to be minus I. Are you getting or not? So this is not minus k, basically this is minus I direction. Are you getting or not? So let me rub this one. So this is minus I direction. Are you getting? So I have to have, this is minus I. So let me put it here. So this is minus I direction. So this is minus I, this is again minus I, but the magnitude is mu naught I by 4 pi r in the minus I direction. So we will have this time mu naught I by 4 pi r. So this is mu naught I by 4 pi r. And this is minus I direction. Are you getting? Now if I take the magnitude, I have to take the root. So what is the magnitude? So this is I you have one together. So let me first write vector form again. So this is equals to mu naught I by 4 pi r. This is minus k, and for I will have mu naught I by 4 r plus mu naught I by 4 pi r, and this is along minus I direction. Are you getting? Now if I take mu naught I by 4 pi r common, so what I will have, if I take mu naught I by 4 r, let us say or 4 pi r. So if I take mu naught I by 4 pi r common, so here I will have simply minus k, and what I will have here, so this is pi plus 1, and this is minus I. Are you getting? So this is minus I here. Now if you are interested in magnitude, so magnitude of b will be, so square root of b z square plus b x square. So this means you will have mu naught by 4 pi r and under root, so this is simply 1 and this is pi plus 1 whole square. Are you getting or not? So this is the final answer. Now let us discuss the part C. So this is slightly tricky one. So if you see part C, there is a current that goes here. So this current is I, but this current divert into two parts. So this is a, let us say, resistance is 3 part of the 270 degrees. So this is a 3 times bigger than this one. So total current is I. So what should be the ratio of current? In this direction you will have current that will be divided. This point and this point V is same. So I can apply V is equals to IR. So let me first divide the current. So I can explain again. So you have this wire and there is a current that is entering and it leaves at an angle of 90 degree. You see this current is I and this leaving current is again I. So what is the current in this wire and what is the current in this wire? You have to have V is equals to IR. So let us say, you can solve yourself. So this is I1 and this is I2, and if I show Kirchhoff law, I1 plus I2 is capital I. Are you getting or not? And V is equals to IR. This means I1 into R1 is equals to I2 into R2. But R2 is basically 1/3 of the R1. So this is my R1 and this is my R2. So now I can say I1 by I2. This is equals to R2 by R1. And R2 is basically 1, so 3 times, less than 3 times. So you see R1 is 3 times. So this is R2 by R1. I1 by I2 is equals to R2 by R1. So there should be R1. So this is R1. Are you getting? So R1 is basically 3 times more. So this is 1 by 3. So now I can solve for I1, I2. So I1 is equals to 3 times I2. So I1 is equals to 3 times I2 plus I2 is equals to I. So this means I2 is equals to I by 4. This you have done without even doing all this calculation. And I1 is 3I by 4. It should be. So I1 is 3I by 4. This is not 3I2. I1 is basically 1 by 3I2. So this is I1 is I2 by 3. So I have to have this gone. So this is, I will have 3 plus 1, 4I by 3. So this is 4I by 3. Are you getting? So this is not I by 4. So this is 4I by 3. So let me have this one. So this is 4I by 3. Are you getting? So this is 4I by 3. So this is again I1 is, so I2 is 4I by 3. So we can calculate I1. So let us calculate I1. So what is I1? So if I calculate I1, so now this is not R2, this is R1. So this is equals to R2 is basically less than R1 and R1 is 3 times because this angle is 270 degree and here angle is 90 degree. So R2 is basically 1 times and R1 is 3 times. So I will having I2 is basically 3 times of I1. So let us call this as equation number 2 and I have to solve these two equations. Are you getting or not? So if I solve these two equations, that is first is I1 plus I2, that is equals to I. If I plug this equation, I2 is 3I1. So I1 plus 3I1 is equals to I. So what I will have? I will have I1 is equals to I by 4. Simple. So similarly you can calculate I2. So this will be 3I by 4. Are you getting or not? Now if I know I1, I2, we have to calculate the magnitude of magnetic field. So let us see for B. I will discuss one by one. So let us say for this wire, this infinite wire, so this is going in this direction, so magnetic field due to this, so this is in by x plane, so magnetic field has to has in k plane, and this is going in this direction, that is minus k. Are you getting it? Verify yourself. If you point a current in this direction, so that you see if your thumb is going in this direction, then it has to curl in this direction. So at point O, this is in the minus k direction. Are you getting or not? So this is mu naught I by 4 pi r minus k. So mu naught I by 4 pi r minus k. So this is mu naught I by 4 pi r into k, because minus I have written early. So mu naught I by 4 pi r into minus k. Now let us say this wire. So this is in y z plane, so only 270-degree wire. So this is not complete circle. So due to complete circle you have magnetic field is mu naught I by 2r. So this is 3/4 of circle. So due to 3/4 of circle you will have magnetic field is mu naught I by 2r into 3/4. So let me first write the magnitude. So magnitude will be mu naught I, and I is I1 by 2r into 3/4. Are you getting or not? What is the direction? In this I have written current is I1 because current is not capital I. What is the direction due to this? This is in YZ plane. We have said already, if you curl your finger in this direction, it has to go inward, that is minus I. So this is the direction is minus I. Minus I cap. Let us say third part. If I have third part, that is again circular part. So if I consider this part, that is mu naught I by 2r, but this is 1/4 of the circle. So 1/4 of mu naught I by 2r, and this is a positive I direction. So this is simple. So this is mu naught I by, and I is I2 in this case, divided by 2r, and this is 1/4, and direction is plus I. Are you getting or not? Now next part. So what you should have in the next part? This is in xy plane, no, xz plane. So this is in xz plane. So this wire is in xz plane. So magnetic field has to have z component. Now if you run the current in this direction, this means your finger should run in this direction. Are you getting or not? Or you try to use the screw rule. If you have a screw, if you try to open this screw so that it can come this side, then it has to move in this direction. This means at this point this is in minus j direction. Initially I have written minus k, that is basically wrong. Now this is in minus j direction. So we will have magnitude is mu naught I by 4 pi r. So mu naught I by 4 pi r, and this is minus j direction. Are you getting or not? Now see, if I see this value, these two things are basically cancelled to each other. I1 into 3 by 4 is nothing but I2. So let me check. I1 into 3 by 4. No, I1 into 3 by 4. I1 into 4. 4 I1 is equals to I2. Or let us say plug the value of I1, I2. So I will have. So let us say this term. I am interested in this term and this term. So let us say Bx component. Bx component. What you will have? So mu naught by 2r. And in place of I1 you have to have I1 is I by 4. So I by 4 into 3 by 4, and this is minus. Now from here what you will have, that is mu naught I by 2r, and R2 is 3 by 4i, and this multiplied by mu naught I by 4i, 2r into 4, and this multiplied by 1 by 4 and into I. So I component is plus I. Now see, this value are same. So 3 by 4, 3 by 16. So 3 by 16 into mu. So this means Bx component is 0. This is quite important result. So I will have only Z and K component. What is resultant magnetic field you will have. So you will have K component minus mu naught I by 4 pi r, and this is K component, and here you have J component, that is mu naught I by 4 pi r. Are you getting or not? So this is mu naught I by 4 pi r, and this is minus J component. And if you want to take the magnitude of the resultant magnetic field, so you will have P resultant is equals to, so both are same, so you will have root 2 multiplied by mu naught I by 4 pi r. Simple. Are you getting or not? So this is mu naught I divided by 2 root 2 into r. So this is the magnetic field magnitude you have in part C. So part C is quite good part because this explains how the current is divided into two parts. So you see this is the whole circle, and there is a current coming and there is a current going, and this current is divided into two parts, and due to this at the center magnetic field contribution is 0. Are you getting on why this is happening? Because this current is divided in the ratio of length of circle, and the magnetic field is directly proportional to this length of the circle. This means the theta. Are you getting or not? So what is happening? This theta is the main problem. You have a circle, and in this circle this current is coming in this direction, and let us say this current is leaving in this direction. So there is a magnetic field that depends upon theta. Magnetic field depends upon theta, and this current I1 and I2, this also depends upon theta because resistance depends upon theta. So I1 R2 also depends upon theta. So finally, if they are opposite in sense, so they cancel to each other. So even if you have a very small, you will have same thing. Even if you have a very small part here, so you have a circular section, and let us say a current is in from here and current is out from here, and you say this is a uniform wire, resistance of wire is directly proportional to length. At this point, due to the curved part, the circular part, again magnetic field will be 0. So due to the circular part, so this is the due to the circular part. So this is a quite good problem. So this explains all the concept of finding magnetic field. So if you are happy with this, that's